Good morning all, thanks for tuning in to this webinar today. My name is Chris Crome, I'm an application engineer at CADline, and today we're going to be looking at surface analysis and styles in AutoCAD Civil 3D 2013. So on the agenda for today, we're really going to be looking at the default surface styles we have at our disposal, and I'm going to be using the UKIE template to demonstrate this. We'll move on to how we can create and edit surface styles in Civil 3D, and then move on to applying surface annotation, a bit of surface analysis, ending with a cut and fill exercise. Okay, so this webinar is really set up to follow on from my colleague Trevor Clayton's webinar. He did one earlier in the year, and it was really all about going back to basics, and it was how to create different surfaces from sort of varying data types. Okay, so natural progression from that. Once we have our surface in the drawing, how can we apply styles to it? How can we edit them? How can we annotate it? How can we perform analysis on this surface? Okay, so that's what we're going to be looking at today. I jump straight into civils, and I'm going to start my new drawing. I'm going to make sure I start it from the 2013 UKIE template. In doing so, when I open the drawing, if I just come across to my tool space, okay, so just as a refresher, in tool space we've got our perspective tab, all the drawn data that we have in our drawing, okay, all the Civil 3D data, it's going to be housed in Prospector. Okay, so I like to think as Prospector as the control center for Civil 3D. If I flick across to the settings tab, this is where we house all of the styles that we can apply to everything that we draw in Civil 3D. Okay, so particularly looking at surfaces today, if I expand surface and surface styles, within the UKIE template which I started from, I have all of these surface styles which I can apply to any surface I create in the drawing. Okay, so we're going to start by creating our existing ground surface. We're going to give it a name, e.g. for existing ground. I'll do it in uppercase. Okay, and notice the default style which I'm going to apply, which is a triangulation. So when we first create our surface, it's going to appear as a triangulation. That's because we have this set here. We could change it at this point. I'm not going to. Just going to leave it as triangulation, click OK. So we've created a surface placeholder, but we don't actually have any data yet in the drawing which I can apply to that surface. So if I expand existing ground definition, these are different forms of which I can apply data to my surface. Okay, so this is what Trev would have went through in his earlier video demo. I'm going to add in a point file, and the point file is going to be a PENZ, comma delimited. I'm going to browse to my file. When I bring it in, zoom extents, this is the surface that we've created. Okay, it's a triangulation surface. Okay, notice the style is triangulation because when I've gone in and created my placeholder, I've told it to choose a default style of triangulation. Okay, so how can I change that style now? In civils we have a contextual ribbon. When I select the Civil 3D element, I'm going to get this contextual ribbon giving me all the options available for that selected object. So in our case, our triangulation surface, existing ground. If I come across into the surface properties, on the information tab, I've got a chance to rename the surface, apply a description, but more importantly, I can use this drop down and apply a default surface style. Okay, so it was selected at triangulation. I can change this to contours 1 and 5, for instance. So this is going to be a style which has contours with 1 meter minor increments and 5 meter major increments. If I apply and OK, notice how the surface changes straight away. Okay, so I don't now have in the drawing triangles and contours. I've got one object, it's my Civil 3D object, and I've got contours of 1 meter minor and 5 meter major. Okay, so what actually dictates that this surface is a contour surface? Okay, let's dig a bit deeper into the settings of the styles. So I've just applied a contours 1 meter and 5 meter style. If I right click, I can edit this style I can start to see its properties. On the display tab in particular, notice we have this set up a bit like Layer Manager in AutoCAD. We can see all the different components that we can have switched on and visible in our surface style. Okay, so what makes this a contour style is the fact that we've got our minor contours switched on, our major contours switched on, and our border. Okay, so if I was to turn the major and minor contours off and turn triangles on, click apply, notice how our contour style is actually now a triangulation style. So it's the components that we have switched on in that surface which dictates what sort of style it's going to give us. So if I turn my major and minor back on, this time let's say that I want to set up a surface style which actually matches the CAD production, okay, which I need to send out the door. So everyone has their own CAD standards at their companies. Okay, they might like to send contour surfaces out which have a green minor and a red major contour. Okay, and let's say a grey border. If I apply that to the surface now, that style is set up within this drawing. If I created a .dwt template of this file here, it means that every time I came in and started a new drawing from that new template, my contours 1 meter and 5 meter would already be set up to match my CAD standards and the output that I needed to deliver. Okay, so setting these default styles is really important for efficiency through the life cycle of your project in Civil 3D. Okay, so that's a contour drawing, or that's a contour style I should say. We have some other styles already set in the defaults. I won't look at all of them, but I'll look at a couple of other useful styles. I can apply a border style, for instance. If I select the surface, come up to surface properties, I'm going to choose that border style, apply, and OK. So if I wanted to do some design work within the boundary of my surface, but I didn't want all the contours or all the triangles sort of obscuring my view, I could set a border only, which reassures me that the surface is there. I've got the border showing the outline of it, but I've not got all of this distraction in the middle. Okay, I can take that step further, changing the border style in surface properties. I can set to no display. Okay, no display. Takes the surface right out of the drawing, visually. Okay, it is still physically in the drawing. If I go back to Prospector, I can still see I've got my existing ground surface here. Okay, I've just hidden it from view. Okay, a bit like freezing a layer or turning a layer off in AutoCAD. Okay, I've just turned those contour layers off and the border. Okay, so I'm left with nothing in the drawing, but it's still there. If I want to turn it back on, I can come across to Prospector, existing ground, go into surface properties, set back to whichever style you want applied. Okay, we'll take a look now at actually creating our own surface style. I think we'll do it by copying an existing one. So this contours 1 meter and 5 meter that I have applied. I'm going to come down to it in the settings tab of surface styles, right click, and I want to copy. Okay, so we've already looked at the fact that this style is defined by the layers we have switched on. So I might want to keep these layers switched on, but let's say I want to change the color of my minor contour, but also I want to change the intervals. So at the moment I've got contours 1 meter and 5 meter applied. Let's say I want to change those to a 2 meter minor with a 10 meter major contour interval. Okay, how can I do that? First thing I'd like to do is change the name. So obviously I'm going to get rid of this copy and I change it to the relevant intervals that I want, so 2 meter and 10 meter. Also in the description, mimic that down. Okay, but now I need to actually define that 2 meter and 10 meter in the surface style itself. And I'm going to do that in the Contours tab. In the Contours tab, notice we have a Contour Intervals drop down, minor interval of 2. Notice how it suggests a major interval for me of 10. Okay, so I can come in and actually change that retrospectively. Just so happens that that's the major interval I wanted anyway. Click Apply, and OK. Notice the style doesn't change because I don't have that new style applied to this surface. The style's been created in my settings of surface styles. Okay, so it should now be an option when I come into my surface properties. Use the surface style drop down to apply the contours 2 meter and 10 meter. Select it, click OK. Now I've got a contour style which is 2 meter minor contour, 10 meter major. Okay, all set with the colours which match the desired output that I want for this surface. Okay, I'm just going to revert back to triangulation now as we look at some of the sort of analysis techniques for surfaces in Civil 3D. First thing I like to do is always look at my surface in a 3D view, okay, to understand exactly how it's been triangulated. Okay, if I select the surface, I can come across into Object Viewer at the top. In Object Viewer, I've now got an isolated 3D view of the surface where I can navigate around and understand exactly what the terrain on my site is doing. Okay, the reason I have this sort of render applied to the surface is because whenever we look at the surface from a triangulation surface style in Object Viewer, if we apply the realistic visual style, we'll see the render that's applied to the surface. We can change that render material by going into the surface properties. Okay, we've looked at surface style, but here we have render material. If I use the drop down, there are some defaults in the list. Okay, we can import new materials into here. But if I go for grass short, for instance, click apply and OK. This time if I go into Object Viewer, when I look at the triangulation style in realistic visual style, I have this new grass short render material applied. Okay, some more tips for you. If we go now back to our contours 1 in 5. So we've looked at our surface in 3D. What if we want to take a quick section through the surface? I can just draw a standard polyline going through the surface. Okay, just going to select both of those and look in Object Viewer just to show you that the two are totally separate. Okay, the polyline was drawn down at 0. Okay, all the contours are up at their appropriate level. Okay, even though they are at different levels, I can select the polyline, right click and choose Quick Profile. Quick Profile will allow me to draw a section through as many surfaces in the drawing as I'd like. So I only have one, it's my existing ground surface, e.g. Okay, it's been given an automatic profile style. So that's the style of the line, the cross section I'm going to produce. I can change that profile style, I can create my own, I can edit these. The existing ground is going to be a good style to have, it's going to be a dashed green line. Okay, you can also apply a profile view style. This one will have a 5 times exaggeration to the vertical. Okay, there are other options, I can even have it in natural scale. 5 times should be fine for me. I'm going to click OK. Ask me for an origin of the section, I'm going to click above the surface. Okay. You should notice I get a very quick long section through the length of my polyline through my surface. Okay, and those two are now dynamically linked. If I change the location of the polyline, notice how the long section updates automatically. Okay, and I can do that as much as I want. Okay, notice if I stray from the surface, it's just going to show that in my profile with a gap. Okay, I've kind of described this quick profile as a sort of rough and ready long section, and you know, the profile itself is as accurate as a long section can be, just the information we have on the profile view itself is limited. Okay, so there are better ways for presenting long sections in civils using alignments and surface profiles. We're not going to go into that today, that will come up in a later webinar. I just want to let you know that this is really a good way to interrogate the surface as you're really going through and designing. Okay, the two, like I say, are dynamically linked. If I delete the polyline, the long section will go as well. Okay, we'll go into some annotation techniques now. I've obviously got this contour style set to the surface. Okay, how can I come in and annotate the surface now? Annotate the contours. Select the surface to get the contextual ribbon. I've got the add labels drop down at the end. 3 at the bottom relate to labeling contours. So I'll go through each, starting with contour single. When I select it, all I need to do, I don't have to snap. Okay, but if I click close enough to a contour in the surface, it's going to go in and label that contour at the place that I've selected. Okay, so very quick and very easy. Notice how it's applied different styles to the minor and major contours. Okay, so 2 separate styles, we can control how those labels look. The minor obviously has 3 decimal places set to it, and is slightly smaller than the major, which has no decimal places. All the text that we create in civils is annotative. And what that means is we actually dictate the height that we want the text to be in paper space. That way it doesn't matter how often we change our viewport scale, the text is always going to display at the right size in paper space. And we can get a preview of what that text will be like by changing the scale of our model. So if we know our viewport's going to be at 1 to 2000, we can select 1 to 2000 and we can see how that's going to look in the drawing. Okay, so we're no longer in a scenario where you need to create copies of text just so you can change the text height to be in a viewport of a different scale. Okay, just creating one set of text now. So that was labeling single contours. We can also label multiple contours. Okay, this time I'm sort of going through the same technique I do to draw a polyline in CAD or Civils. I'll select my starting point and I'll select my end point. Okay, next time I click the mouse, what it's going to do, it's going to insert a contour label every time this line that I'm drawing crosses a contour. So I click here, every time that line crossed a contour, it's dropped in the label for me. Okay, so very quickly labeling multiple contours. I can take that a step further, add labels, contour multiple. This time contour multiple at interval. Starts in the same way. I'm going to click my start point, click my end point. Only this time I can apply an interval left and right of that line, which is going to put a label for me. So 100 meters left and right. Okay, so my existing line was drawn through here. 100 meters left and 100 meters right, it's put in more contour labels along the entire length of that line. Again, I can change my model scale or the text size or update automatically. Just going to delete all those as we move on to looking at some other annotation techniques. One of the most common is going to be adding spot levels. If I click add labels, spot levels, every time I click within the drawing, it's going to read off the surface value at that point. Okay, so each label is telling me the spot level, the actual finish level of the existing ground at that point. I can come in and I can drag these around by clicking the node at the insertion point of that point and moving that level around. Notice how when I move it around, the value updates. Okay, to correlate with the actual level of the surface underneath it. Okay, I can also use AutoCAD commands like copy to create more labels. Again, every time you put them down, it's going to read the surface level. I can also use a move command to refine their location. These labels are also set up with particular properties for a dragged state. So I can actually move this value a bit further away from the point, okay? So if I needed to make sure none of my text was clashing, I could use this node at the top to actually drag the value further away from the point. Okay, and this is set up to actually have a leader which points me back to the point it relates to. More common labeling techniques will be to add slope labels. Add a slope, and add them in two ways, 1 point and 2 point. If I add a 1 point slope, every time I left click, it's going to tell me the dominant fall at that point. Okay, notice how they're all shown in percent. Okay, I can change that to rise run. Okay, so these slope labels have a label style. This current label style is set to show the value in percent. If I come across to AutoCAD properties, I can see the label style that's being applied. I can use the drop down. I've got some defaults already in the UK template that I can change to. So I've got rise run, for instance. Change it to rise run. Now going to change to 1 in 27.78. And I could refine that style further by getting rid of the decimal places, by rounding, and by dropping the negative sign. Okay, I'll just show you the second option for slope. It was to add a 2 point. Okay, so this time it's not going to tell me the dominant fall, but I can ask what's the slope between the level at that point and the level at this point. Okay, and it's going to tell me the slope in that direction. Okay, it sort of disregards all the level information in between, so it's just reading off the level at the start and reading off the level at the end, and it'll tell me the slope between those 2 points. Okay, useful tip: if you've got a big drawing, lots of labels, and you want to select just the slope labels, for instance, select one, right click, and you can select similar. So only going to select labels that have similar properties. So right click, notice that all the slope labels are selected, all the spot levels aren't. So I can go in and erase the slope labels, leaving the spot levels. Useful little tip for you. I'm also going to erase the spot levels too. Okay, I'm going to show you a couple more tips with surface analysis before we move on to a couple more styles, and in particularly look at some cut and fill. I'm going to select the surface, and I want to use this water drop. So this is a bit of an extension from the slope, the 1 point slope showing the dominant fall. Every time I click my mouse now, it's going to show me the flow path of any water dropped at that point down to its lowest point. Okay, I can do this as many times as I like through the surface. Okay, but if I zoom into one of these, notice that these two are draining to the same point down here. I can take this a step further by selecting the surface and applying a catchment area to that low point. So I want our civils to work out the catchment area for this low point here. I can snap to the end of my water drop. This will draw a polygon for me, and it's telling me any water that falls within this area is going to drain down to the exact point. Okay, so it's using the 3D information from the terrain that we have, and I can check this by selecting the surface, and I'll do more water drops. Anytime I click within this surface, it's draining down to my low point here. So these tools are really good for an existing scenario. If you've got an existing ground topo, you've got locations of existing gullies, you can check the catchment area for each of those gullies. But you can also use it to check your proposed designs. If you've gone through and designed a proposed surface, okay, you've put in a pipe network with some point drainage, you can go in and check that you've put your gullies actually at your design low points. I'll go through and delete those whilst I quickly show you one other style before we set up a cut and fill scenario. When I go into surface properties, the surface style I'm going to show you is a 2D solid level banding. and select the style, and then come across to the Analysis tab. In the Analysis tab now, we can set up a number of ranges, which if I run this 8 ranges, notice how it split my surface up. So defined by the level of the surface. So I've got the minimum level of the surface, the maximum level, and they split it up into 8 ranges. Okay, so apply the color scheme to each range, so that I know if I apply that to the surface, okay, I know that when my surface is between 27.787 and 33 meters, I'm going to have this color applied to the surface. Okay, so I can start to get an understanding of the actual levels of my existing site, but sort of based on a sort of isopachite sort of style. If I click OK, that style means nothing to me in the drawing unless I have a table to go with it to actually tell me what values are assigned to these colors. If I select the surface, add legend, I'm going to add a levels legend, which is dynamic, put it in the drawing, and you see the table style for this legend is set to have the number of ranges, the minimum and maximum level for each range, and the color that's applied to each. That table is now dynamically linked to the style. So if I go back into surface properties and decide I actually only want 4 ranges now, I can rerun the analysis. I'm only going to get 4. Apply. It's going to change the color of the surface style, and the table will update because I've set it to dynamic. Okay, that's going to be a good little introduction to our cut and fill exercise. What I'm going to do is change my existing ground back to contours and create a very simple secondary surface, which will be my proposed surface. I'm just going to do it from a rectangle going through the site here. I'll set it at a generic level. Really just getting us to the stage that we've got 2 surfaces in the drawing. So I need to create a new surface in my prospector. I'll call it comparison, and to that comparison surface I'll add as a break line my rectangle. Okay, I've got this triangulation here now, which is my comparison surface. If I go into Object Viewer, you can see it's just a flat surface. Okay, but I've got 2 surfaces in the drawing now where I can compare the cut and fill between the 2. So what's the level difference between the 2 and what's the cut and fill volumes? Okay, I don't need this surface switched on, so I'm going to set it to the no display style. And I want to work out the cut and fill between the 2. I do that in civils by creating a triangulation volume surface. In Prospector, Surfaces, right click, Create Surface. Okay, so we've got a type which is triangulation surface. That's what we've used for our 2 surfaces we've already got in the drawing. To calculate the cut and fill, I want to change that to triangulation volume surface. Notice in the window below that gives us the option to set a base surface and a comparison surface. So I'll name the surface cut and fill, the volume surface cut and fill. And I'm going to add in a base surface which is existing ground, and a comparison surface which is comparison. Click OK, click OK. Notice the style set to triangulation, so click OK. It will look like I have a triangulated surface, but this is in fact a volume surface. If I go into the volume surface, surface properties, change it to this time 2D solid cut and fill. This surface style is set to be very similar to the level banding we just applied. But this time when I run my ranges, it's not looking for the surface level, but it's looking for the depth between 2 surfaces. So my volume surface is a comparison between our existing ground and our comparison surface. Okay, it's going to list out the maximum and minimum depth between the 2. And again, it's going to apply a color scheme to each of those ranges. I'll just change the legend to cut and fill volumes. If I apply that, and OK, notice how my volume surface has changed from the triangulation to this cut and fill isopachite now. And the same way as before, if I select the surface, add legend, and add a levels legend, it's going to be dynamic. I want it in the drawing here. This table style, which was cut and fill, now shows the number of ranges, the minimum level and maximum level relating to the depth, the colour and the plan area, and in particular the volume for each range. So we can split the volume in between those ranges. But if we want a total cut and fill volume for that surface, we can do that a slightly different way. We can come into the Analyze tab and use the Volumes dashboard. Okay, if I load the Volumes dashboard, in the Volumes dashboard what we can do is load in triangulation volume surfaces. So I've got one in the drawing, it's cut and fill. As soon as I load it in, it's going to tell me details, particularly the total cut, the total fill, and then the net cut or fill. So I can see for this I'm left with quite a lot of fill. Okay, we can refine that cut and fill further. Let's say this is our development boundary, but the development is set into separate phases, of which this is phase 1. Okay, so what happens if I just want to know the cut and fill volumes for phase 1? What I can do is add a bounded volume. Okay, so using the cut and fill that we've got for the whole site, I can add a bounded volume where it's going to ask for the bounding object, which is my phase 1 boundary. Now when I expand it down, I've got this cut and fill point 1, which tells me just the cut and the fill within this boundary here. Notice how it's highlighted in red. I can change the title to phase 1. Switch both those on. I can generate a report which lists out the total cut and fill for the site, but for phase 1 we've got a net fill of said value. Okay. One last tip I'm going to show you with volume surfaces is that if you ever need to show on a drawing annotate it with a spot level which shows the depth between two surfaces, use the volume surface. If I select this volume surface, add labels, spot levels, when I come in, okay, I'm having some graphical issues. Okay, I was going to show you one last tip, but I'm just having a couple of graphical issues there. So I think I'll hold it there. There was only going to be an extra addition. I'll write a blog about it, about adding spot levels showing the depths between two surfaces. But generally today we've gone through, if we go back to the head screen, we've gone through the surface analysis and surface styles we can apply in Civil 3D. So we have our default styles in the UK template. We've gone through, we've edited them, and we've shown you how to create your own. Okay, particularly trying to match your own CAD standards to really make delivery of drawings a lot more efficient. So this video and webinar has been recorded. It'll be posted up onto the CADline community. And if you've got any questions regarding the content of the webinar today, feel free to email me directly, chris.crome@cadline.co.uk. Otherwise, I hope you found the webinar useful, and I hope that you'll find uses for it and be able to apply it in your Civil 3D designs back in the office. Okay, thank you very much for your time today.